Hello, my name is Marcella and I'm taking Technology 1010. So I'm doing the assignment Nanotechnology and Friction. First, I want to state the principles, the 5 laws of friction. Number one is when an object is moving, the friction is proportional and perpendicular to the normal force. The second one is friction is independent of the area of contact. So as long as there is an area of contact, friction will be independent. Then the coefficient of static friction is slightly greater than the coefficient of kinetic friction. So an object that's not moving will have greater friction than one that is moving. Fourth is within rather large limits, kinetic friction is independent of velocity. And the last one, friction depends upon the nature of the surface in contact. So then I was investigating how friction, has to do with nanotechnology and how are they related. First of all, after stating the laws of friction, I need to explain that friction is a force and it's measured by newtons. Friction comes in various types. For example, static, that means that's not moving, kinetic, that's moving, and rolling. And we will begin our study, we began our study, by stating and listing the properties of friction. And I'm going to state some other, those were the laws, but now I'm going to state their properties. And it's essentially an electrostatic force between two surfaces. It can only be between two surfaces. Never initiates motion. It only responds to motion. Depends on the materials that are in contact. Depends on the net force, normal pressing the two surfaces in contact. Acts parallel to the surface that are or might have the potential to be moving in respect to each other, and opposes the direction of motion. This is one of the main properties of friction, opposing the direction of motion. Also, it is independent of the area of the surfaces in contact. So some scientists have been studying how friction relates to nanotechnology, and they've been creating nanoscale devices based on moving molecular components have the potential to radically alter technology such as energy storage, drug delivery, computing, communications, and chemical manufacture. A team of nanotechnology researchers from the University of Pennsylvania and Columbia University, they have used friction force microscopy to determine the nanoscale frictional characteristics of 4 anatomically thin materials, discovering a universal characteristic for these very different materials. Friction across this thin sheets they used increases as the number of atomic layers decrease. So this is one of the properties they found when they try to use nano scale materials, all the way down to one layer of the atoms. This friction increase was surprising as there previously was no theory to predict this behavior. So they're still studying it, and they don't know exactly why this is happening, and they're trying to figure out. They're studying, nanotechnology keeps developing every year, and they keep studying it at the nanoscale because friction is a property that has been forever, and now they want to apply it to nanotechnology because nanotechnology keeps innovating science. Also, researchers found the friction progressively increased as the number of layers is reduced on all 4 materials. Regardless of how different the materials may have been chemically, electronically, or in bulk quantities. This measurement, supported by computer modeling, computer modeling suggests the trend arises from the fact that the thinner a material, the more flexible it is. So it's like a single sheet of paper is much easier to bend than a thick piece of cardboard, and that's why they came up to the conclusion that maybe that's why the friction was being higher because of the material they were using. Also, materials with low friction and adhesion are desirable for avoiding premature failure. So they're still studying it and studying how the properties of nanotechnology and friction can relate and how they can slow down friction, or depending on their main purpose.